All right, everybody. Here's the second hypothesis test for difference of mean. This is going to be an interesting particular video because in this case, instead of having the standard deviation and the sample mean given to you, you're given a table. So I'm going to sort of show you, and you're going to just have to follow along as I figure out the sample means and the sample standard deviations for males and females. There's a way to do it on these TI-30XA calculators that I'm going to go through. You might need to watch my video a couple times to see how I'm doing it. But I'll try to be as clear as possible so that you can see how I'm figuring these things out. So for the purposes of numbering things, we're going to call males 1 and females 2, just because they this is the first column, this is the second column. Now we know, so we're asking, do males buy more meat at the grocery store than females? As always, we're going to be using alpha equals 0.05 in this question. And a random sample of 5 males and 7 female shoppers were asked after leaving a store, and they got the following data. So with this data, and you're going to see this if you're in my Stats 2 class, you're going to see this in your test. I'm going to give you, in a lot of questions, the data, and you're going to have to know that you can figure out the mean and the sample standard deviation with that. But to do it, it requires sort of having the right calculator and knowing how to work through it. Sometimes you might have a calculator a little bit different than this. There's ways to do this without necessarily having this calculator. If you have a different variety, I'd ask that you try to look it up to figure this out. If you're working on your assignment, you can also figure it out online. There's calculators of these. But yeah, so let's try it this way. Now, remember, a small sample is when N1 and N2 are both less than 30. Here we have N1 equal to 5, because there's 5 men who were sampled, and N2 equals 7. So we are going to be dealing with a small sample size, so this means we have to use a t-distribution. Okay. All right, so let's figure these things out. So we need to know what is x1 and what is s1. x1 bar, because again, so what we're going to have to do is, because this is the t-distribution, and now here's the formula we were using last time when we had a large sample size, but we're going to use this one the next time. And it's a pretty long one because it's got this extra SP term in there, but this is the one we're going to use. So we're going to need to know x1, we're going to need to know n, we're going to need to know s1. And you say, oh, we need to know SP. Well, SP gets figured out. SP squared gets figured out with that formula. So x1, here's what we're going to do. So to figure out all that stuff, what you have to do is you have to enter that data into your calculator. Now, the way to do it is, so let's say we start with the first one, 18.53. Do you see this little button right here? You press that, and you get n equals 1 here. That just says how much data is entered. So that entered it into the memory. And let's go with the next one. We have 13.08. We enter that into memory as well. 7.5, we enter that into memory. 22.3 into memory. And then lastly, 10.11, enter that into memory as well. That puts 5 in there. Now, the way we do something with this data, do you see these little green numbers? X bar, sigma of xn minus 1, sigma of xn. This right here is the mean, the sample mean of that data that you just entered. This here is the sample standard deviation of the data, and this is the population standard deviation. These are the two you're going to be using, because you're always taking a sample and figuring out the sample standard deviation and the sample mean. So x1, second function, because we need to access those green buttons, and we press this button right here, gives me 14.304. So 14.304, and to figure out the standard deviation, second function, this button, 6.066, we'll say. We'll do 2 decimal places just to be more accurate. Now for females, x2 bar. So now we're going to turn it off, turn it back on. That resets the memory. We're going to enter all the females in. So 14.32, this button right here. So now there's 1 data point. 15.9, enter this one. There's 2. 23.8, there's 3. 9.65, There's 4, 13.9, 5, 14.98, that's 6, 16.00, that's 7. Now, you can do this with any data. This doesn't need to be just for these problems, okay? Sometimes I'm going to give you problems of all the types you've seen before where you just have a table. And in that table, you have to figure out X bar and S by itself. But I'm using this as an opportunity to show you how to do this with your calculator. So right now, we're not even doing hypothesis testing, okay? We're not even doing hypothesis testing. We're just finding the data we need. So second function, X bar, that's going to give me my X2 bar, which is 15.07. And then S2, we have, oh no, I reset it. Oh, actually, it's still in the memory. So second function, standard deviation, what I get is 4.238. Okay? All right. Okay, so now we're going to take that data and we're going to do our hypothesis test. So what you should always do is when you're given a table like this, figure out, you know, it doesn't matter what question you're on. If you see a table and you start computing your mean and your standard deviation, you're never going to go wrong. You at least have that data available for you to use in your problem. So let's go through it. The first step, where's that sheet that I had again? First step, state the null hypothesis. Do men buy more meat at the grocery store than women? Well, if you're trying to test if men buy more meat than women, you have to start with sort of a basic assumption. The basic assumption is there should be no difference. The difference between these two, this minus this, should be 0. And then you have an alternative hypothesis. Well, the alternative hypothesis is that men buy more than women. So that would mean that mu1 minus mu2 should be greater than 0 because this is only greater than 0 when mu1 is bigger than mu2, right? In other words, mu1 is greater than mu2, right? And what that means is then, so this only happens when, mu1 is bigger than mu2, and then this is bigger than 0. 3, we have to figure out our rejection region. Well, we know that this is a t-distribution problem. It's a small sample size because n1 and n2 are both less than 30. And that's when you have two different variables. The number of the sample size being less than 30 in both cases is what decides whether you're small sample size or a large sample size. Okay, so let's go through this. We're using a t-distribution, and what we need to figure out our t-distribution is we need our degrees of freedom. Well, the degrees of freedom in this case are a little bit different from your normal degrees of freedom. What they should be here, because there's two variables, we have n1 plus n2 minus 2. Okay, that's your degrees of freedom. So this is going to be n1 is 5, and then plus 7 minus 2. So this is, I'm getting 10. I'm going to figure that out. So the degrees of freedom are 10, and my alpha is 0.5. Is this a one-tailed or two-tailed test? That's the first question we have to ask ourselves. Well, this is not a not equals sign. This is a greater than sign. So this should be a one-tailed test. It's in the positive side because this is greater than 0, so it's going to be on the positive side. And from here, and you know what? If this were negative, if this were less than 0, it would be down over here. It would be negative, but it's positive. So T alpha, what's this going to be equal to? Bust out the table. You have 0.5 right here. You have 10 right here. I get 1.812. 1.812. Okay. All right, so now what we have to do is we have to determine, so if this is T alpha is equal to 1.812, when I figure out the test statistic, is it going to be above that? So now remember, this is sort of a complicated formula. So T equals x1 bar minus x2 bar. So the sample mean for men, sample mean for women, minus the difference. Well, the difference here is 0 because we're just trying to test if there is a difference or not, divided by the square root of SP squared 1 over N1 plus 1 over N2. Okay, so this is going to be 14.304 oh wow, 14.304 minus 15.07 divided by square root of, well, we're going to figure out SP squared down here, because remember, SP squared in and of itself is a complicated formula. So well, maybe actually we'll do it over here. So we'll say SP squared, try to fit this all in. Let's make a little side here. SP squared is equal to N1 minus 1 times S1 squared plus N2 minus 1 times S2 squared, all divided by N1 plus N2 minus 2. So this is going to give me N1 minus 1, that's 4, times S2, or S2, or S1, sorry, S1 squared, so 6.066 squared. So this is times 36.796 plus 6, sorry, because N2 is 7. 7 minus 1 is 6. Now S2 squared, so that's 4.238 squared. So this is 17.961. And then on the bottom, divide by N1 plus N2 minus 2. So N1 is 5. So 5 plus 7 minus 2 happens to be equal to 10. Okay, so we have 4 times 36.796. So that's 147.184 plus 6 times 17.961. So that's plus 107.766. All of that's going to be divided by 10. So we're going to add that 147.184 divided by 10. So I get SP squared is equal to 25.495. So this is going to be 25.495 down here. This is going to be 1 over 5 because N1 is 5 plus 1 over 7 because N2 is 7. So you can see it's a little bit of computations. It takes a little bit of time. 14.304 minus 15.07 is equal to negative 0.766. Okay. Then on the bottom we have 1 over 5 equals plus equals and then times 25.495. What was that time? Sorry. So that's 0.2 plus and times 25.495, and then I get the square root button. So on the bottom I get 2.957. So we have 0.766 divided by 2.957, and what do we get? It's equal to 0.25. Well, negative actually, in fact, negative 0.259. Okay. So what's that mean? Well, negative 259, this is actually going to be over here. Negative 0.259. This is actually a really good example because we haven't actually had anything like this before in any of the videos I've done. But this is an example of where we actually fail to reject. So in 5, what we can say is that we fail to reject the null hypothesis because it's not in the rejection region. And, you know, it's kind of topsy-turvy here when you go from 5 to 6. What this means, though, is we failed to reject it. So what we're saying is that there is actually insufficient evidence to conclude that men buy more meat than women. Okay, and this insufficient evidence, that's key, okay? Whenever you fail to reject, it means there wasn't enough statistical evidence available to you to make a firm conclusion on that particular hypothesis test, okay? So that's, this is going to kind of be your template for when you fail to reject. In 5, you say, I fail to reject the null hypothesis. In 6, you say there was insufficient evidence to conclude that, and then you talk about whatever the problem is. In this case, men buy more meat than women. We were testing to see if men bought more meat than women. We checked it out, and it turned out there was insufficient evidence. So that's how we do it. Thank you very much. I'll come back with pair differences in my next video.